Hello everyone! Let's review today methods in OSPF which are used for route filtering. But before we continue, I would like to ask you to subscribe to my channel with notification bell on and please show your support by hitting like button. So let's talk about it. Route filtering is the method which helps to selectively identify routes which are advertised to or received from neighbor routers. There are some advantages of using route filtering. First one is traffic flow manipulation. So if you remove some routes from some routers or from areas, it causes changes in traffic flow. Reducing memory utilization. With route filtering, you reduces LSDB or reduces routing information base, and it helps to reduce memory utilization. And the last one is it is improving security. If you don't want propagation or advertisement of some routes into some areas, you can block it with route filtering. There are three methods of route filtering. First one is filtering with summarization. It can be done on ABRs or ASBRs during route summarization. Second one, area filtering. You can use prefix lists to filter out some routes in the areas. And the last one, local OSPF filtering with distribute list. When you still have this route in the LSDB, but you can remove it from to prevent it from ejecting into routing information base on the specific router. In the next few slides, we will review each method with examples. Before we continue, let's review network diagram which is going to be used in examples. We have network with 7 routers. We have loopback interfaces configured on R2, loopback interfaces configured on R3, and loopback interfaces configured on EIGRP. There are 1, 2, 3, 4 areas, and area 0 is on routers R1, R4, R5. Router EIGRP running EIGRP and router R6 running two dynamic routing protocols, EIGRP and OSPF, and there is route redistribution from EIGRP into OSPF. So let's continue. One of the easiest and simplest methods of route filtering is filtering with summarization when you add keyword not advertised during OSPF route summarization on ABRs or ASBRs. When you use this keyword not advertised, it prevents creation of type 3 LSAs on ABRs and type 5 LSAs on ASBRs for any networks in that range. It makes routes visible only within the area where they originate. To configure filtering with summarization, you can use the command area ID range IP address network mask and then add keyword not advertised on ABRs, and on ASBRs the command is summary address IP address network mask and then again keyword not advertised. Okay, let's see this example. This is the network that I showed on the previous slides, and everything already configured like IP addresses, OSPF, EIGRP, and let's just verify show IP interface brief. So as you can see, we have loopback interfaces with network mask 24 and router R1 show IP interface brief. Everything is good. So I can focus on configuring route filtering. So I'm going to filter these routes, which we can see here, for example. Show IP route OSPF. These routes 192.168.1, 2, 3, 4, 5. I'm going to filter them on router R1. Show IP OSPF database. Router R1 created type 3 LSAs for these networks 192.168.1, 2, 3, 4, 5 and advertised them into OSPF domain. Show IP OSPF database. As you can see, they are also presented on router R4. So let's configure route summarization. Router OSPF area. This is area 12 range 192.168.0.0 and subnet 255.255, and then we need to filter we need this third octet is going to be 248. This is our summary route. And if I want to filter, I need to use not advertise, but just let's do summarization. And as you can see, router R1 already created type 3 LSA for this summary route. And to show IP OSPF database, and it is also presented in here on R1. So let's add not advertise. Show IP OSPF database. It is presented here. Show IP OSPF database, but it disappeared on router R4. So it's gone also here for summary type 3 LSAs for area 0. There is no more. We had it summary route, and we had all these routes before, but now when I configure it summarization, route summarization with keyword not advertise, it prevented creation of type 3 LSAs into OSPF domain. So let's see, show IP route, and as you can see, we don't have these routes in our routing table. Let's check. We had them before. It was inter area routes, and now we don't have them anymore. Next, let's do configuration. Let's do filtering on ASBR. R6 is ASBR, and this router EIGRP, it has some loopback interfaces. These loopback interfaces this is our ASBR, show IP protocol. As you can see, it has OSPF running and EIGRP. And it has a distribution of EIGRP routes into OSPF. So, and let's check also show IP OSPF database. As you can see, there are type 5 LSAs created for these subnets on loopback on EIGRP router, and we can see them, for example, on router R5. Show IP OSPF database. They are also presented here. So I'm going to filter. First, I'm going to do summarization as I did on ABR for these 3 routes, and then I'm going to filter them out. So let's do it. Conf T router OSPF 100, and then we need to do summary address and then IP summary address. This is our summary route. Summary address 172.16.0.0 and network mask 255.252.0. And then we have this keyword not advertised, but for now I just want to do summarization. And let's see, show IP OSPF database. We still have them. And now they are gone. We have only summary route. So we had all of them, and then we did summarization, and now we have only one link summary address for these subnets. And let's see on router R5. You can see type 5 LSA for this summary route. And now let's configure filtering. T router OSPF 100, and then we should have it not advertise. Show IP OSPF database. Still have. Let's see here. And now, as you can see, it is gone. So we had it, this some type 5 LSA for summary route, and now it is missing here. Let's see ISBR. And it's also disappeared on ISBR. So this summary address summarization on ISBR with keyword not advertised prevents type 5 LSA creation. And now we should not have show IP route OSPF, and we are missing those subnets in our routing table, like external routes for those subnets on loopback interface in EIGRP. So this is filtering with summarization. Filtering with summarization is very easy and simple method, but it has its own limitations. For example, if I want subnet 192.168.17 to be present in area 0 but to be filtered out from area 45, I cannot do it with summarization on ABR R1, because if I do summarization, it prevents type 3 LSA creation for summary route, and it's going to be missing in area 0 and in area 45. For this task, when I need, for example, 17 to be present here and missing here, OSPF has different method of filtering, and it's called area filtering. It supports filtering when LSA type 3 generation occurs. Original route gets installed into the LSDB of the router for the source area, and then route can be installed in the routing information base of the ABR. Filtering can be done in both directions, either inbound or outbound. You can see when router receives LSA from area 0, it installs it into LSDB for that area, and then installs into this routing information base. And it can be filtered inbound or outbound. For example, on ABR, if I want to do area filtering on ABRs, it can be done inbound from area 0, it can be done outbound for area 12, and outbound for area 13. For example, on ABR R4, I can do it outbound for area 0 and inbound for area 45. And OSPF area filtering can be done with the following command on the ABR. Area ID filter list prefix, and then prefix list name, and then you need to specify either it needs to be filtered inbound or outbound. Let's see this in example. For this example, for area filtering, I added two loopback interfaces on router R6, 100 and 101, and I'm planning to filter subnet 192.168.17.0 which is for loopback interface on R3. And I'm going to filter this subnet on router R5, leaving area 0 or outbound from area 0. And I'm planning to filter this subnet for this loopback interface on R5, entering inbound to area 0. Let's verify that we have this route, show IP route OSPF. We have our 100 subnet route to the subnet, and here we should have show IP route OSPF. We have route to subnet 17. So let's go to R5, and we need to configure two prefix lists, which one is going to filter subnet 17 and the other one 100. IP prefix list, because we are going to apply them in different direction. IP prefix list filter 1, sequence 10, and then I need to deny 192.168.17.132. I'm using this form with mask 32 because OSPF advertise loopback interfaces with mask 32, and IP prefix list filter 1 sequence 20 permit. I need to permit everything remaining for this prefix list. And let's create second one, prefix list filter 2 sequence 10 deny 192.168.101 net subnet 32 and network mask subnet 32, and second one sequence 20 again permit everything remaining. So we have two prefix lists. Now let's go to configure router OSPF 100. Let's configure filtering. So it's gonna be area 0, and then we need to use filter list, and then we have prefix, and then I need to specify prefix list. So I'm going with this filter list and this prefix list, I'm going to filter subnet 192.168.17. So this is filter 1. This filter 1, and then it's going to be applied outbound from area 0 out. And second one, area 0 filter list prefix filter 2 into area 0. I'm going to filter 192.168.100. So let's go and see show IP route OSPF. As you can see, route on subnet 100 disappeared on router R4. We had it here, and on R5 show IP route OSPF, and we have it on router R5, and we have on router R5 subnet 17, but it should disappear on router R6. Show IP route OSPF. As you can see, it is missing. This route to this subnet is missing on router R6. We had it, but now it is missing. So as you can see, it can be configured area filtering outbound or inbound for area. Sometimes we need to filter one specific route from routing table from one specific router in an area. And for that we can use local OSPF filtering. And local OSPF filtering uses the distribute list to achieve this goal, which is to prevent a route from being installed in the local routing information base, but still gives the router possibility to maintain identical LSDB for the area including filtered route. Let's review this diagram. When router receives LSA from neighbor, it installs this LSA into the LSDB and then processes inbound distribute list. If inbound distribute list denies route from being installed in the routing information base, so routing information base on the router is missing this route. It means that route can exist in LSDB, but it could be prevented from being installed into local RIB. But Type 3 LSH generation occurs before the processing of the distribute list, and it does not prevent Type 1 LSAs from becoming Type 3 LSAs in different areas on ABRs. On ABRs, the regeneration process of Type 3 LSAs, which are coming from the backbone area into a non-backbone area, is being prevented by distribution list because it happens after the distribution list is processed. A distribute list should not be used for filtering of prefixes between areas. The local OSPF filtering can be done with the following command. Distribute list, then you can use one of these options. ACL number, ACL name, prefix list with prefix list name, route map with route map name, and then keyword in. So let's review local OSPF filtering in example. So the same network that we used in the previous examples, and for OSPF filtering I'm going to filter some routes on router R4. For this OSPF local filtering, let's say I want to filter this route 192.168.20 for loopback 192.168.21 from routing table from router R4. Show IP OSPF database, and as you can see this router is presented in LSDB, and let's check router R5. Show IP route OSPF, and we have this route on router R5. So when I filter, it should be present also on R5, but should be filtered on R4. Let's do it. Let's configure access list, IP access list standard filter ACL, and then we need to deny 192.168.21 because OSPF advertises loopback interfaces with subnet 32 and permit any. Then we go to our router OSPF 100, and then we need to use distribute list, and then the name of our list filter ACL, and then we need to use keyword in, and then that's it. Let's see, show IP route, and as you can see I don't have this route in local routing table on this router anymore. OSPF database, I still have it in LSDB, and I'm supposed to have it on R5. Show IP route OSPF. I still have it in routing table on router R5 and in LSDB of router R5. Let's do one more small example. Let's filter this route from routing table on router R4. IP access list standard, filter ACL, and then the 15. We're gonna have entry 15 now. Deny 10 12 0 0 0 0 0 255. Show IP access list. So we have second entry in our access list. And then now let's check. Show IP route. Let's do this OSPF. So as you can see, we're missing this route in routing table. We had it, but now we're missing. And let's check on R5. And it's present on R5. It was not filtered out because it's still present in our LSDB and it is type 3 LSA. This was example for local OSPF filtering. Thank you very much for watching my video. I hope you enjoyed it. Please don't forget to subscribe to my channel with the notification bell on and show your support by hitting like button. I hope to see you soon in my next videos, but for now just goodbye and see you soon.